it's going to be presented by the first author, who is called Gleb Rogozinski, and he's here. Well, he's not here. He's here in my computer. He is in the other side of the world, in Russia. He is based in St. Petersburg. His presentations goes like this. He's going to say hello from the video conference, and then we're going to see a video he prepared, and after that we're going back to the teleconference for some questions. Okay, so I'm going to connect the audio. Okay, and so how can I show you there? This? Yes.
Hello everybody. Hello dear sounders. Hello Uruguay. Hello conference.
So here is Gleb, and I'm going to show you the video right now, and then we're going back to you, right?
Sure. Okay.
So let me maximize this. Look at this.
Hello ICSC2017 and all our fellow sounders. My name is Dr. Gleb Rogozinski, and this is Eugene Chorny. I'm Dr. Michael Chesnakov of Nuclear Resource Center, St. Petersburg, Russia. In this video, we are going to tell you about the current status of a project called PCH2CSD, which is actually focused on simulation of famous synthesizer clone of modular G2. Let's start from the brief overview of a non-modular editor interface. All models are grouped under 16 different categories. The oscillator section includes some basic, periodic, and also noise generators. There's also some physical models like OSC string and even famous Yamaha DX7 model. The input-output section includes basic outputs and inputs, and also FX input to route the signal to the FX part of the patch. The filters include few simple filters like low-pass or high-pass filters, and also some more elaborated ones. There's also a voice modeling filter, a 16-channel vocoder, and some equalizers, of course. The LFO section consists of several LFO generators of different complexities, and also there is a clock generator needed for any sequencing. There are several envelope generators available in Nord Modular, including classic ADSR, and also some simpler envelopes and some more flexible ones, like multi-stage envelope generator. Shapers includes different modulus for wave shaping, like clips and drives. Mixers include multiple kinds of mixing modulus to mix different signals. FX section consists of stereo chorus, phaser, flanger, digitizer, frequency shifter, pitch shifter, scratch simulator, the reverb, and the compressor. All the buttons and selectors are in the switch section. There are also several types of sequencers available in Clavier, including small node sequencer. MIDI section includes typical MIDI-related models, like note send or control receive. The note modular patch consists of two parts. The VA stands for voice area, which is the subject of polyphony, while FX is a global FX part. I will demonstrate now the creation of a simple patch. Let's grab a simple oscillator, which will produce a sawtooth wave, and connect it to the output model, which is like sound outs. Notice that the A-rate signal is a red color cable. Please notice that Node Modular supports output-to-output connection. This feature made our work a bit more difficult at some stage. Now let's include a low-pass filter with resonance. So we feed a signal through the filter. Of course, we may tweak some filter parameters directly. Now let's use the LFO unit to modulate the cutoff frequency of our filter. Notice that the control rate cables in Clavier are blue ones. Now let's try some different thing. Let's bring up a simple decay type envelope and connect it to the patch. As you may see now, some models can change their behavior from audio rate to control rate and vice versa. Now we take a simple sticks and steps sequencer and then sync it to the clock generator. The yellow cables are used to route the impulses. The one-step rhythmic sequence now will trigger the envelope. Now let's delete the clock generator and try to retrigger the envelope using LFO. This is an example of type conversion. So the blue cable or control rate signal is converted to another control rate signal of pulses, which is a yellow cable. Finally, let's add some effects using global effects section. So we need to place a desired effect to the effects section and route the signal to it using effects in. This is the stereo reverb. So it was a brief demonstration of programming logic in non-modular synthesizer. Now some words from my colleagues.
I mainly dealt with the problem of low-level parsing as a first stage of the project. Actually, we used the materials of our colleagues, but we not only investigated the structure of original patch files, we also created a converter that adapts the data to another format.
I joined the project later to contribute bug fixes and more features to the converter. But after tweaking around with the code base for some time, I decided to rewrite it from scratch in Python. The old code worked well in general, except it missed some features, but it became hard to maintain with time. In the current state, our tool can parse binary patch files created by Clive's editor and generate the C sound code from specially prepared templates. Next, I'd like to demonstrate to you how the tool works in a screencast that follows in a moment. In this video, I will demonstrate to you how our tool works and explain a bit of details based on some simple example. I prepared a very simple patch for you to just demonstrate. So this patch consists of a single saw oscillator, which volume is controlled by a rail amplifier. So, and then the sound just goes to the DAC. We can try to convert this patch using PCH2CSD command with just one argument. And as the first argument, we need to pass a path to the patch, basically. So let's do this. So yes, this is our new C-Sound CSD file. And we can try to run it. So yeah, and let me show you how it works. So for this, I will open the resultant CSD file and explain how it works. So we have a number of predefined variables like global variables. Also, we generate some function tables we don't currently use, except probably for the saw wave. And so after the static definitions, which come from the templates, go the UDOs, which represent each module, and the main instrument. So, as you can see, our generated code doesn't look like typical C-Sound code. That's because we don't use opcode returns and inputs, so pass signals around. Instead, we use ZAC patching space, which we define somewhere in the beginning of the CSD instrument. And instead of passing signals from variables and somewhere else, we just connect modules internally. So each modules should have some opcodes that read from Z space or write to Z space. So yeah, basically this is it. And taking this particular example, we can see that our oscillator is the source signal. It has 2 inlets and 1 outlet. So these are 2 control inlets and one audio outlet. With this statement, we tell this opcode to read values from the ZAC space, from the ZAC bus 1 for these both inlets, and to output the signal to the 7th ZAC bus. So this one will be passed to the 7th bus. The thing is that 0 and 1 ZAC space buses are special. The 0 bus is a trash bus, so basically can write anything to bus and it will just disappear. And bus 1 is a bus which no one writes to, so you can safely just read from this bus and you sure you always get 0. So this way represent that there is no connection here. And then from the 7th ZAC bus, sound goes to the level amplifier, which happens to have 1 inlet and 1 outlet. So yeah, this is it. And this level amplifier outputs the signal to the ZAC bus 8, which then goes to the out 2, which has 2 inlets, and as you can see, it reads from 8th ZAC bus. So yeah, you just saw basically description how these different modules can connect to each other. So in order to successfully convert a patch, you have to be sure that all modules that this patch uses are implemented by our tool or by you. So to implement the modules, you have to follow some simple rules, and the tool should work, the conversion should work fine. So the main issue here is the number of implemented modules. And we implement modules as opcodes. So one opcode is one module, which encapsulates all things that a module may have, like all the logic and everything like this. And also we introduced some annotations to help the converter to do its job. I won't go into much details about it because we don't have time for this today. And just to get more information, just consult our wiki page on how to create a new module, and you will understand more probably. But I do want to outline some specific features that could be interesting here, at least at this conference. And so there are 2 essential types of annotation introduced. The first one is the arcs annotations. This annotation helps the converter to determine how many knobs or other user interface parameters the module has, and also it helps the converter to determine how many inlets and outlets the module has, and also the types. What are the types of these inlets and outlets? So in this particular example of the level amplifier, we have 2 user interface parameters. As you can see, there is one knob and one switch. And we have one inlet and one outlet. The thing here is the a little bit complex thing here is that the modules can be polymorphic, like this label amplifier. That means that when, for example, this label amplifier by default accepts control rate signals, but as soon as we connect an audio cable to it, it changes its type. And unfortunately, C sound is not very expressive enough to represent all these kind of generic types of logic and things like that. So we went kind of straightforward way just to include two copies of the opcodes, which differ by the inlet and outlet type. And depending on what kind of patch cords are connected to this module in the patch, the converter chooses the appropriate implementation. So to wrap up, the ARCS annotation helps us determine how many parameters the module has, and how many inlets and outlets, and as well as their types. Another annotation is the map annotation. It helps our converter to map the MIDI values that are stored in the patch to the actual values that can be used inside the opcodes. For example, in this particular level amplifier, we have level amp table that maps from raw MIDI scale to some floating point scale, probably like reading and something like this. And one complexity here is that we can switch the scale of some parameter by some other button. And for example, here in the level amplifier, we have switches the scale of this knob from some linear to decibel scale. And our tool can also take these things into account, but as I said before, it will take too much time to explain everything in these details. The last thing I want to mention in this particular screencast, we have a special page that is generated every time we build a project, and it contains a status of all implemented modules. By looking at this page, you can understand kind of how many modules are already implemented to some degree, and what modules need some attention, or maybe some of them are not implemented at all.
That's it, folks. Thank you for watching our video. I hope you enjoyed. If you want to join the project or help us, please mail us. Bye.
I'm still here. I hope everybody hears me.
There you are.
Yeah, there you are.
Okay.
So
You have a sound of me?
yes. Yes.
Yes.
Okay. So now we can ask some questions to Gleb in case he has some doubts or comments on the work. I don't know if you have any questions. So perhaps we can start. I was wondering if you've done some tests comparing the original, let's say, sounds and the ones you emulated. Could you comment on
Yes,
that?
Yes. Thank you for the question. It's very nice question, actually. I will try to explain. Actually, there's a lot of hardware synthesizers and the digital synthesizers, but most of them are analog modern. So even the very simple sawtooth wave is a bit elaborated one. But in case of Clavier or Modular, their waves are very Gen 7 waves, if you know what I'm talking about. So they are actually their default and actually beyond the A rate possible is 96 kilohertz, and the K rate is 24 kilohertz. There's no options to change it. So the sawtooth, the triangle wave, any other waves are really aligned waves. It's very easy to define. You just have to sample it at the right sampling rate, and you will see that it's just actually Gen 7 wave, no tricks. So it actually was the starting point. So actually the story started from my discovery of this kind. So I just tried to figure if the waves of Clavier are something different to sound wave primitives. And I discovered there's no difference at all. I mean, of course, there's another line between Clavier and your sound card. There's another line, and of course you have some distortion. But of course, the idea of Clavier's angel waves are the same as the sound primitives like sawtooth wave, the last one.
Any other questions? Could you please?
Hi there.
Have to turn it on. Is it turned on?
Hi, Gleb. This is Joachim. Nice to see you there.
Hello. Actually, I don't hear you well, so if you please amplify the volume.
It's better now.
Is it better now?
Yeah, a little bit. Yeah.
Okay, my question is very simple. What do we need to install the software?
I'm so sorry, I didn't hear it well. Maybe if you're able to come closer to the computer, or
yeah, he asked what do we need to install the software. If you want to use it, what do we actually need? Is that?
Excuse. There's some disconnects. Could you please? I'm sorry. Could you please speak it again?
Yes, of course. The question, I guess, is what do we need to run the software? What do we? What do we need to install? Is that clear?
So you mean kind of prerequisites, right?
Yes.
Actually, it's very easy. You have to install the Python. I guess the newest branch of Python, and pipe utility to install Python software, and you just install PCH2CSD, and actually the whole procedure is just few lines of code and documented on our side project on GitHub.
Hello, Gleb. This is Mike. We would also need to have some patch files. Do you have a collection of patch files in your repository that we can use?
Did you hear it?
Did you ask about if their submodules are already implemented, right?
No.
What I'm asking is, where can we get PCH files?
Okay, I got it. Actually, there is a very big collection of PCH2 files on the web. actually there's still functional community of not modelers. So unfortunately, I'm not able to directly tell you the URL of them, but it's very easy to find. Like you just have to Google for Design Modular 2 community, and there's a whole library of patches, and also there's a demo editor of Modular 2, and it's still able to be run on some old machines, and it actually working editor, so you may be able to create your own plugin without any hardware needed.
Fine. And are you aware of any other synthesizer of this type in which you have a big collection of patches that perhaps would be a nice idea to emulate too?
Thank you for the question. What I'm going to try to do is like, do you have plans to implement some other synthesizers, right?
Somehow, yes.
Actually, I guess it's logically after some advantages in implementing of Client Modular 2 to try to implement actually the first Client Modular 1, because actually the first not modular is even simpler. So if we will be lucky with this second and the last version of not modular, almost automatically we'll get the first version working. And talking about some principally different synthesizers of the era, well, actually the Clavier was kind of the only one kind of software hardware modular synthesizer. But we are looking forward to spread this idea of evolution or inheritance of technology using Cezanne to some other software hardware solutions. So yes, we're looking forward to, but I'm still not able to tell you some strict plans because we are focused right now on this exact synthesizer.
Okay, I see. Anyone? I think that's it. We may thank you again, Gleb, for the talk and the work.
Thank you for this possibility.
Please, the next we have to move forward to our next talk and say goodbye to Gleb. Right?
Bye.
Bye. Have a nice day.
Thank you, Gleb. See you. Yeah, so we need a few minutes because the authors of our next paper want to use their laptop, so we need just a couple of minutes to fix it. Sorry. It's true. This one here? Okay. Eso si no está ahí también, eso sí, copiar. Sí.
Así sí, ya la aprendí al final. Sí, sí.
Sí. Okay. So we're going, yes. So we're going to our next paper, and we have here the authors. Fortunately, they are Guillermo Sena, yes, and Juan Nava Arosa from Universidad Nacional de Rosario. We are going to talk about a framework for composing and rehearsing. It's called Daria. The paper is entitled Daria, a new framework for composing, rehearsing, and performing mixed media music. Okay, thank you.
Thank you. I think the spoon is not fitting. That's better.
Hello everyone, we are very glad to be here. So, our presentation will be about a new framework we may call Daria, for composing, studying, rehearsing and performing mixed media music. What is a mixed media musical piece? So, let's first start by defining what is a mixed media musical piece. You all may already know this, but just so that there are no mix-ups regarding the translation. In Spanish, we call the mixed medium to a piece of music, which is there is an interaction between both acoustic and electroacoustic instruments. Given the inclusion of virtual electronic instruments, mixed media music represents new and exciting possibilities, given this relatively new combination of the traditional way of making music with computer technology. But we have to say that mixed media is also a way of writing music in which the format itself brings with it its own set of problems. Some of the problems that arise when a composer writes a mixed media musical piece are: how can the human performer study the piece while staying in sync with the electronics? This is a problem because the composer has to come up with a system that not only has to work during the performance and the concert hall, but it also has to allow each human interpreter to study his or her part at home, preferably while listening to the electronic part. Computers are still hard to use. Let's face it, we are not there yet with the ease of use regarding computer. We believe that studying a new piece should be a pain-free experience for that kind of people that may be great at playing the piano, but maybe not so good at understanding why you should set your period per buffer radio to 3 when you are using a USB audio interface. Virtual instruments are rarely used. The traditional way of doing music was to have a clear separation between instrument maker and composer. This allowed the composer to reuse instrument and explore each instrument as much as possible. As much as possible, me perdí, perdón. Sí. With the advent of computer programming to music, this practice has been somewhat lost, and each composer creates in all virtual instruments, even doing it in per-piece basis. This is not necessarily something bad, but by doing it so, we may by excluding a lot of composers that could benefit from the old paradigm of music in which you compose for already existing instrument. Each agent has its own creative space with different means for specialization. At least in our context, only a few composers have a multi-channel speaker setup at their home studios. And probably not a single interpreter has a 4 or 8 channel speaker system at home to practice. Use of proprietary software. Leaving aside the ethical implication of using proprietary software, a specific issue related to mixed media music has to do with the use of proprietary format to set the code of the virtual instrument and or the composition itself. This could be a problem in the near future, when some of the work produced to that code by impossible to be represented. Etc. These are just partial lists, and they are obviously other difficult involved. Human-machine problem. We'll focus now on the specific problem we were trying to solve when we begin to develop Daria, which is how to obtain in sync. One of the biggest challenges in performing mixed media music is how to achieve the correct synchronization between human interpreter and the playback of pre-recorded song, and or also the synthesis or processing of audio in real time. No standard solution. Although composers and developers have tried to come up with a solution to this problem, we don't think there is currently something in the work in a unified manner. How can we teach in them? Well, as a result, it isn't very clear how to deal with that kind of musical practice in the classroom, or at least the solution won't be the same everywhere. In universities where the syllabus is oriented toward the quote-unquote traditional way of making music and not so much toward music and technology, teaching that kind of human-machine interaction becomes a real problem. Possible solution. 1. To force the human interpreter to follow a tape. 2. To use a click track. 3. To trigger event from a MIDI or some other kind of controller. 4. To use a shared virtual clock. 5. To use a score following or gesture following, etc.
So now speak Daria a little bit. So introducing Daria. What is Daria? Well, as we say at the beginning, Daria is a new modular software framework for composing, rehearsing, and performing mixed media music. Specifically, it's a way of writing musical scores with MuseScore, sync them to VSTs that were made using Cabbage, and all of that by making them follow the JAX audio server transport mechanism. So how Daria should work? Where Daria relies on the fact that both MuseScore and Carola have the ability to sync with JAX transport. And our development process began with the creation of a QML plugin, QML being the language that Qt, or Qt as you want to pronounce it, that's the language used, QML, for developing extensions for MuseScore. And so that plugin, what it does is it surveys the musical score, it extracts information, for example, how many bars there are, how many measures, how many beats per measure there are, pitch information, rhythm information, and it then sends that information by using the OSC protocol to all the VSTs that were made with Cabbage. The main VST is called the Conductor, and it's shown there at the top right part of the screen. And the Conductor will be our way of interacting with the JAK transport. And that is all in relation to the basic information that was received from the musical score. Like, for example, how many measures there are, how many beats per measure, etc. So that would be the most basic Daria interaction you could have, the score and the Conductor. But we also created, for presenting this paper, 2 additional VSTs. A random audio file player called Random Electronic Sound, and a loop machine called the Looper. So we also have to create a short musical fragment in order to use them and show how they work. And here we see basically a flute part that would represent the acoustic instrument parts of the musical score, and then 2 additional musical parts. The RES part will talk to the RES VST, and the looper will talk to the looper VST. We also had to build more than 5 different opcodes, seasonal opcodes, for the whole system to work. They were all written not so good, they are in prototype state, but the system currently works. And so here's the Conductor, and we see a transport control, where we can see 4 buttons. We have previous measure, stop, play, and next measure. Then a previous countdown display that will allow the instrument players to synchronize with the system. Then we can see a time display where there is current time in green, and also in red we can see the total duration of the piece. Then the yellow bar, it shows the measures position in regarding the virtual shared timeline that JAX gives us. And in green we can see the beats position in relation to the measure. So here it would be a 4/4 notes long measure. And the red lines that you see that are separating the measures and beats are automatically aligned in that timeline, and we have to modify Cabbage in order to do so. So we created a special version of Cabbage that synchronized that lines. So here's a more simpler GUI, the Random Electronic Sounds, that just has a scan, rescan button to scan the folder from where it will pick up the audio files, virtual LED, bypass, pan control and gain control, and the looper, also the same, gain control for both channels, pan control for both channels, channel 1, channel 2, and output control. So what would be the pros of using Daria? Well, it's a modular system. It should grow through the creation process of the community. It's free software, and like free speech and free beer. It allows you to make VSTs with Cabbage and sync them to a musical score. It allows you to reuse all the VSTs that the community already made. That's what we call async mode. And that's because it works asynchronously from the jack transport mechanism. But you could load a river, for example, there, and it would be no problem. It also allows you to sync your work with other Jack-aware applications. Like, for example, you could have the X video monitor from Jack, XJVideo, and load a video and have it sync with the rest of your project, with the musical score and all the VSTs. And finally, it can be present at all stages of a musical production. That means instrument design, composition, while studying a piece, while rehearsing, and while performing. So Juan will now talk about how the process would be if we were to write a mixed media piece.
10 minutes, right?
So, let's say I want to write a mixed media piece. First, I have to think about what all the acoustic and electroacoustic instruments are going to be. Let's assume for the first list that I'll write for violin and clarinet to have an idea of what those instruments sound like. I can search for good sound font on the internet and then load them in MuseScore's internal synthesizer. For the electroacoustic instrument, I have to think, it's fixed media. That means, while I design and complete its soundtrack, I have its playback synchronized to the musical score. Oh yes, and then I produce a WAV file with C-Sound or maybe just a sound editor, and then I load it inside Escuela. Or no, well, there is something more complex than just the playback of an audio file. Does that instrument already exist in VST form? Yes, it loads it in Escuela. Or no, then does it need to stay synchronized with jack transport mechanism? Yes, so I'll develop my new instrument following a Daria template for Couch. Or no, there will be just usual programming in C-Sound/Couch. And no matter what, in the end I have my VST that I have to load in Escuela. Once the VSTs are loaded in Escuela, I ask to myself, does it depend on information contained within the musical score? Yes, then I must write a part for in the MuseScore. Or no, I can optionally write a part for it in MuseScore so that the rest of the interpreter know what the particular instrument is doing. And if the instrument in real time control, and I can get away with using conventional music notation, I can also optionally write a part for it in MuseScore. Finally, does the VST need to be operated in real time? It does. Then it is probably a good idea to write a MIDI track so that the interpreter can use it as an automation track for that instrument when they are studying the piece. What should the interpreter receive from the composer? One, the musical score saved as a MuseScore file. Two, a Escuela project file containing the list of all the VSTs, audio track, and MIDI automation, along with the state of the patch bay. Three, each VST that was exported from Escuela. 4. Fixed media if there is any audio file used in the composition. 5. MIDI track automation, if there were any of those used. 6. The sound font for MuseScore, if the composer wished to give the interpreter to change to listen to the same song he was using while composing. Optionally, the composer can create a synchronized audio track with commentaries by section or per instrument. This could be an interesting way of preserving the way in which the composer wanted his or her piece the song through history. After that, each interpreter will have to mute his or her part in order to study the piece while listening to the other simulated performance. A rehearsal and performance. 1. Some phone must be suppressed, or at least the MIDI connection from MuseScore. For MuseScore should be undone. 2. Automation must be suppressed or mute inside Kava. The musical score and the VST GUIs can be shown by means of 1. Using a projector. 2. Having clone monitor display coming from a same computer. 3. Having several computers, including Raspberry Pis, synchronized through NetJack. Finally, a multi-channel VST can begin to record each part automatically, including acoustic instruments that are being captured through mics.
Okay, so we'll now see a video of something we recorded maybe in June or July of this year. So here's the setup. At the top part of the screen we have MuseScore, and don't pay attention please to the musical score, is some random notes. They're just some random notes I place inside MuseScore. The piano there would be representing the acoustic instruments, the treble clef of the piano, and then the tambourine is speaking with the random electronic sounds PST, which is here. It doesn't have the new graphical implementations, but it's the same thing. And the claves will talk to the looper, which is here. And at the bottom part we have XJ here, which has loaded a video file from just some random video I pulled from YouTube. And so you'll see the countdown part start to advance, and when it reaches 5, which is the 5 seconds we define here, the conductor will start to move its vertical bars, horizontal bars. There is information being transmitted to the DSPs. And I can also reposition the transport from inside the conductor. And even while the playback is on, I can also go back and forward. Well, that will be the video. And So we will end with some questions. What would be the cons of using Daria right now? And we'd like to thank our reviewer number 2, where he or she was, because most of these questions were his questions. So he said, isn't the use case for Daria really specific? We don't think the use case for Daria is really specific, because you can do interactive music as long as non-interactive music. Because we are using Carla as our BST host, we can load audio files to Carla and do tape music if you like. Because we are using Jack and XJAudio, we could also possibly do multimedia pieces or intermedia pieces or whatever you call it, where you have video synchronized with the playback of the sounds. So everything that may be interactive electronic music or non-interactive electronic music and that has a score representation would be a good candidate for Daria. He also said you're using a lot of different software. What would happen to your project if just one of them gets abandoned? Well, we don't think that's very much a problem because everything is open source, so we could potentially pick up from where it was left or just refocus the whole project and look for alternatives. And he said, why not just export a MIDI track and import it in C-Sound? Well, first of all, the note tone and note off events in the MIDI protocol won't let you position the transport in the middle of an event. And second of all, one of our goals was always to make a project that is both simple and user-friendly for non-technical people, we would say performers, someone that plays the piano 8 hours a day, something like that. But also because we have C-Sound at the back end of the project through Carriage, it is flexible and we have that powerful audio engine at our backs. So is it really free software if you're using Steinberg's BST technology? This is a gray area. We are not lawyers. We have to read Michael's paper on GitHub. He said to me recently that he wrote something about it, so we'll read that. But we think it is possible, because of other research we have been doing, it is possible to redistribute the already made PSCs as long as you don't distribute Steinberg's SDK. So we might be okay. We are also planning on leaving the whole BST technology. That is a path we might take. And is it ready to be used in real performance? No, absolutely not. We have like a whole year ahead. We are planning on switching to InScore, the project made at Grain, and not leaving completely MuseScore, but maybe using InScore for the performance part. And that would also allow us to maybe use an image manipulation program like GIMP or Inkscape, and also have scores that are graphical scores. You could even maybe draw a score by hand, scan it, and then import it in GIMP, and using the same logic with the plugins, have it in InScore. Make Jack optional, then maybe abandon the VSTs and use Couch 2. Rory Walsh has been doing amazing work with Couch 2, and we have the Couch Patcher, which would allow us to replace the BST host we are using, that strategy of using Carla as a BST host. Maybe executable Couch master projects. This is an idea I would like to discuss with Rory. Add Jack transport to Carriage. And finally start creating virtual instruments and using the system with real musical pieces. So we are sorry for our broken English, but thank you for listening, and we'll take questions now if you have them.
questions, and I think you almost answered them all at the end.
Well, review number 2 was great.
Yeah, that's it. I was also wondering when this will be ready to be released, and you answered.
Yeah. We don't know.
So we don't know, right?
Oh.
And
I have a question comparing this with Macs, which a lot of people use for this purpose. Are there major features in Macs that you don't have, or are there features that you have that they do not have?
I don't know how to make the comparison, because this is basically a music notation editor, like for example Sibelius or Finale or MuseScore. We're using MuseScore, and then the VSTs through CSOund with Cabbage. So I don't know, we potentially could do everything with audio because we have CSOund covering our backs, and I don't know, music notation. I think that there is no real comparison unless you say you could interface Sibelius with Max or something like that, which I don't think you can, because their plugin base is not so good.
Yeah, I don't know about that myself, but I know that you're going to get questions like mine.
Oh yeah, sure. Yeah. Thank you.
Is this for both Mac and PC?
It should be. Everything is multi-platform, so yes. And if we switch to InScore, we also get mobile, because InScore is in Android and iOS.
yeah, is there another one? Yeah.
Thanks. First, this is a very interesting approach. I'm still not quite clear if I have the situation that, for instance, a piano player practices a piece for piano and tape. Is it meant for this? And
Yes,
is it then more to find a specific point and to play the tape from that, or did I miss anything?
You could use a piece for piano and tape if you just have your WAV file and you load it inside Carla, and when you press play in the conductor, the MuseScore software will start to play back synchronized in a synchronized manner with the tape piece. And you could also have another VST recording the whole interpretation, multi-channel, for example, VST recording the whole thing separately, the piano part and the tape part. Well, the tape, you don't have to record the tape, you already have it, but it could be a way of doing that. And the piano performer, if you say you have 2 or 3 acoustic instruments, like human performers, you could give them your audio file to them. They go home, each one of them loads the track, for example, in that case, in Carla, and they all study the piece in having it synchronized with MuseScore. So that would be, it's the most simple case if you like, but yes, possible.
Would it be an idea to extend this to by score following? I mean, to be able to react to the, for instance, accelerando or retardando of the players?
From all the lists of possible solutions we found to synchronizing every interpretation, score following could be added, but we will have to abandon the idea of having a shared clock, which is what jack transport is doing in our case. But yes, it would be a good way to go in 5 years or so. Yeah.
Okay, I think we are over with this. And now, thank you again for your presentation. And we have a lunch break now, right?
5:30 we have the second paper session, so you have 1 hour for lunch. Before 6 we have to leave the building, so we cannot go behind schedule too much.